Any other hand? Now Kabiro has her hand up.
I think the Pascal's principle states that when a pressure exerted at any point on the surface of a confined liquid, the pressure is transmitted equally throughout the liquid.
Okay, thank you so much. Yes, you give us your answer also.
Pascal's principle states that the pressure exerted on an object immersed in water gives the same upthrust force according to the weight of the object immersed in water.
Yes, Haula. Nice one. Yes, Amara, if you have an answer.
Which I wanted to correct on my statement for Pascal's principle. So Pascal's principle, in my understanding, is like when pressure, when like applied pressure is like transmitted through an enclosed fluid, it is equal. Oh yeah, it is equally transmitted throughout the entire fluid.
Okay. Okay, I think those are the answers that I have for the statement for Pascal's principle. We're going to state it here. It states that when pressure is exerted at point and enclosed, someone told us confined, which is also fine, confined fluid. It is equally transmitted throughout the liquid. It is throughout the liquid and in all directions. So this is the statement for Pascal's principle. it is stating that when pressure is exerted at one point or at a point on a liquid or a fluid which is enclosed or confined, then it is transmitted equally throughout the liquid. And some books add that in all directions. Someone is raising up their hand. We will see that later. Okay, so that is the how we can state the Pascal's principle. The other thing people were stating was not anywhere close to the Pascal's principle. There were some people who were talking about upthrust. It is not anywhere attached to upthrust. Pascal's principle is attached to pressure in the fluid. So they are telling us if pressure is exerted at one point in the fluid, that pressure is transmitted equally throughout the liquid or throughout the fluid. Okay, so after knowing that, I want us now to come back to our lesson. We look at the applications of that principle and how it relates to fluids in an enclosed fluid. Yes, your hand is up. What do you have to say?
As in the first application of pressure, according to Pascal's principle, one is the hydraulic break and also hydraulic press. Is it hydraulic press or lift, that one?
Okay, thank you.
Welcome.
He's telling us about the applications of the principle. He's telling us that one is the hydraulic press, the other is the hydraulic lift. So we are going to, by the end of this lesson, be able to explain the applications of the principle, and then we see how we can relate it to calculations that we will see later. Now, the first application is the hydraulic brake. So I want you to pay attention, and we see this video here, and we see how a brake applies. And then after, so we are going to see this video, and after we have seen it, I will have to answer some questions after. So I want you to pay attention. I'm sorry to ask, are we all not getting the volume? Are we all not getting the volume? Yes?
Teacher.
Mm-hmm.
So the thing is that, yeah, to the diagrams that we studied about school, yeah?
Sorry?
On the hydraulic brake, yeah? Like on your image, we can't see the slave cylinder, the brake shields, the return spring.
No, this is a video trying to explain how it works. It doesn't give us a diagram, eh? It is just telling us how this thing happens. So I was just asking if you were getting the volume or not.
Actually, I wasn't even getting the volume. That's why I just thought it's just a couple of slides.
Okay.
Yes.
Let's see what to do. Yes.
So by the time the video was playing, your mic was muted, so we were all not getting anything.
So can you get something now?
Yes, I can hear you speak.
No, I want you to hear the video itself.
So you play. So I'm not hearing.
Okay, I think I'll have something else to check later.
Yes. Maybe.
Okay. Otherwise, I think we should go back to let us just have a diagram drawn. We see how this thing happens. Now, the hydraulic system, either a press or okay, now I want us to look at this diagram that we have here. It is a diagram that I've got straight from the net, but I want it to help us to get a clear explanation of the brake system. Now, if you look at this diagram, we have many things around it. First of all, we have a pedal here. Then the pedal is connected to what they have called a master cylinder. And in the master cylinder, above it is an oil reservoir. And then there is a pipe that connects to another cylinder, and that cylinder connects to the shoe or the brakes that we have. Now, what happens is that when you press the pedal at this point, this pedal will push this one here inside. In other words, it is exerting a pressure in the master cylinder. Because there is a fluid, there is oil that is in here. So when it presses this piston in the master cylinder, that piston will push the oil in the pipeline, and that oil will move with the same pressure that has been exerted on the pedal. That oil will move up to cylinder 2. And cylinder 2 also has pistons which are connected to these shoes of the brakes. So what happens is that when you push here, the pressure will be transmitted throughout the oil up to when it reaches this point where some part of the oil is going to push this shoe here, whereas the other piston there will push this shoe here. So what happens is that at the end, when you press the pedal, we are going to see the brakes being applied. The car is going to stop, or it's going to reduce on its speed because of pressure that was exerted at the pedal and has been equally transmitted from the master cylinder to the cylinder 2, which is attached to the brakes of this car. So that is briefly how the Pascal's principle works in such a reservoir, a car brake system. Yes, Ivy, you have a hand up. Ivy.
Okay, sir.
Thank you. Yes.
Thank you. Sir, I've not understood very well. Are you trying to mean that in this hydraulic braking system, the pedal first, it's the pedal to go fast, and then the brake? Okay, I've not understood.
Of course, you cannot, the car cannot brake before you press the pedal, because in the car there is a pedal for brakes. So it is you to first apply the pressure on the pedal, and then all the other processes will follow. The pressure applied on the pedal will push the piston in the master cylinder, and in this master cylinder there is oil inside there. So that oil will be pushed, because of the pressure you have applied on the pedal, will be pushed through the pipeline into the cylinder 2, and that same pressure will be exerted to the shoes or the brakes of the car, and that is when the car will brake. That is what I was meaning. Davin.
Okay, sir. I was just inquiring because kinda you are breaking. Okay, like maybe your network, and also that when you're explaining about the braking system, and when they ask like for the applications, can we say it's used in cars? After, like when they ask you, say it is used in cars, then you explain about the braking system.
Okay, so you want, I have not got your question well. Apart from the braking, you want applications for what?
The principle.
Yeah, if they say application of the principle, you don't say in cars. The principle is not applied in cars. The principle is applied in hydraulic braking system of cars. So that is how we state it. We don't say it is applied in cars. We say it is applied in the hydraulic braking system of cars, then in hydraulic lifts or press lift. So we don't say in cars, yes.
Thank you.
Okay. Okay, I'm repeating briefly on the application, sorry, on the explanation of how this car braking system works. And I want you to pay attention such that we can go to something else soon. I have told you that, first of all, it is pressure that has to be applied at the pedal. A pedal is that brake that you see, what you call a brake in the car. So when you press on that pedal with your foot, the pressure that you apply at that point pushes this piston, I'm going to call it piston 1, pushes that piston, which is in the master cylinder, downwards or inwards, because now we see it as if it is inside. So it presses it inwards, and the oil that is in this section here is pushed from this point or from the master cylinder and it goes through the pipeline. So the oil will be moving at a pressure that has been applied at this point. Remember, we said that pressure applied at one point is equally transmitted throughout the whole liquid. So this pressure that has been applied here by the foot that you have put on your pedal is the one that is causing this liquid to move through the pipeline to cylinder 2. So when it reaches cylinder 2, we all see that cylinder 2 is connected to both sides of the shoe of the brake. So what happens is that this cylinder, it also has pistons in it. So once a piston here is pushed, the pressure will also push the pistons in cylinder 2, and those pistons will cause the brakes or the car brake system to work according to the way it has to. So it will push your brakes, and they will be able to stop the tires of the car from moving. So that is how briefly that can work. It works in a way that pressure applied on the pedal is transmitted equally from a piston, which is in the master cylinder, to a piston, which is in the other cylinder, which is connected to the shoe. And when the pressure is transmitted, the brake is able to stop our tire from moving. So that is how this one works. Okay, after knowing that, I want us to look at the hydraulic press or the hydraulic lift. But before, I have some hands here. Okay, now someone has even sent us a better diagram. I think that we can use that diagram that you see on your screen. Are we all seeing that diagram on the screen? When you press, this is now the pedal that we are. When you press your shoe or your leg on the pedal, this piston here, there is a piston in the master cylinder, this one here. That piston pushes the brake fluid or the brake oil into the pipeline that we are seeing there. And because a pressure is applied at this point, pressure that is applied at this point is transmitted throughout this brake fluid. So the brake fluid is from here to here. So what happens is that the pressure will go throughout the fluid and it will enter in this other cylinder here. This one is the master cylinder. Then this is, they call it the slave because it's the smaller cylinder. So what happens is that as the brake fluid comes in here, it comes in with the pressure that it was applied at this point. So when the pressure, when the brake fluid enters this other cylinder, it will push these pistons that you are seeing here. There is a piston here in purple. There is also a piston here. So the yellow thing in between those pistons is the brake fluid. So this brake fluid, because it has pressure, it has come with from this side. That brake fluid will push this piston this way, and then this piston this side. And when it does that, it will stop the car from moving. I think that one there is a better diagram. Any other question? Any question about that? Okay, yes.
Teacher, like my question goes, if I've taken a look at the diagram, like that diagram, there is a part where in the, let me explain it like this. When you push the pedal, the pressure applied will push the brake fluid in the master cylinder through the brake line, and then it will. What if I want to like continue with my driving? Yeah, question, cause couldn't it be the return spring to help me with it over?
And now the thing is that it is about the pressure. If you exert a small pressure, then even the pressure that goes to the other cylinder will be small. If you apply a small pressure, then if you want to continue driving, that's why we move our foot from the brake system to the accelerator. And if you want to make it just reduce on the speed, you just apply a small pressure. If you want it to stop, then you apply a large pressure at the pedal. So it's the amount of pressure that gives you the output at the other end. Yes.
Teacher, another question goes on like this here. If you have taken a look at these people that make drifts on the roads, why is it that every time they make a drift, they have to go and then they change their tires?
Sorry?
If you have taken a look at these people that go for racing games, such stuff, yeah, or people that make drifts with their vehicles, a question is like, why is it that they have to go and change their brake systems and that?
Now, sometimes because of friction, because if you look at these brakes, if you have ever seen a brake, it's somehow metallic, inside. There is some material they use. Now, sometimes those ones, remember, if because there is friction, when the tire. So as they do that, there is wear and tear. And remember, these people who are racing are at a high speed and they are at a risk. So whenever those things wear and tear, they have to be replaced. That's why, since they are using them a lot, they are breaking a lot, then that's why they have to keep on replacing them. It has nothing to do with pressure. It is only attached to the friction that is between those shoes and the tires. Look around there. Where are we? Now I want us to look at the hydraulic press.
Teacher, you're muted.
All right, let us now switch to the hydraulic press or hydraulic lift. And for this, I beg you, we pay attention, because for it, it's also used for, we normally use it for calculation, but the idea that we use is the same thing. So what we are going to do is we are going to have this diagram here. So we have a diagram here. This diagram is an illustration for an hydraulic press or an hydraulic lift. So what happens is that we will be having pressure applied at this piston here. I'm going to call that piston 1. This one here is piston 1. So let me call it A, piston A. And then there is another piston this side, which I'm going to call piston B, this one here. And what is in here is a fluid. Inside here, there is a fluid because the principle works for fluids only, either a liquid or gas. So the principle says that when pressure is applied at this point, when pressure is applied at this point, which is at piston A, the pressure is transmitted. Transmitted means the same pressure that is at this point is moved from that point throughout the liquid until it reaches this piston B. That means the pressure that you have at A, pressure that you have at piston A will be the same pressure that you'll be having at piston B. That is what the principle states as. So they are telling us the pressure at A will be the same as the pressure at B. I will, you will excuse me for my drawing. I think I'll be getting the better diagram later, but I want us to first get the principle
Teacher, in the
how
chart.
this one works. Yes?
Food toasts a better diagram in that chart.
Okay, let me see if let me download this one here. And now I think all of us are able to see that diagram there. So according to the diagram, we see there is a force that is applied at piston. I'm going to call it piston 1. And then there is a liquid between piston 1 and piston 2. This one here is piston 2 here. Now, if a force is applied at piston 1, there is a pressure that applied because we define pressure as the force that is acting normally per unit area. So a pressure that is applied at piston 1, which I'm going to call P1, will be the same pressure that will come to piston 2 here. So that means if you apply a pressure at this point, that pressure will be transmitted equally throughout this blue liquid, and then it will come to this point here. So the pressure at piston 1 will be equal to the pressure at piston 2. That is what the rule says. That means that when you have a force, maybe you want to lift a car, and you put your car at this point. Now we are looking at an hydraulic lift. What happens is that some force will have to be applied at this point. That force will be called the effort. Now, you have to put in some force at this point, and from the principle, that liquid will transfer that force that you have put at this point to go and overcome the load or the car that will be placed at this point. So when you push this one down, you see that our F2 is pointing up. That means that when this force is pushed downwards, then the other side, the piston, is pushed upwards.
Teacher, you're muted.
Yes, I was saying that pressure at piston 1 will be the same as pressure at piston 2. Now, I want you to pay attention to the next thing I'm going to do, this diagram, because it's going to lead us to the calculations that we have in our document there. Now, each of us knows that pressure, if I'm to get pressure, I get pressure from force F out of area A. So that is how we define pressure. Pressure is got from force divided by area. That means if I'm to get the pressure at this piston, the smaller piston, my pressure, we call it P1, is going to be equal to the force 1 that we applied here, then divide by the area 1 of the piston. And my pressure at 2, or at the other piston, at this large piston or the big piston, is going to be equal to the force at that point, so F2, then divide by area 2. So what does it mean? It means that since they told us that pressure at this point is equal to the pressure at this point, that means my F1, if I divide it by area 1, it is the same thing as having my F2 divided by area 2. That is what it means. So it means that this side of the area, my F1 out of A1 is the same as my F2 out of A2. And why is it so? It is like this because pressure at one end of the piston, or pressure at one piston, is the same as pressure at the other piston because it is transmitted equally throughout direction, throughout the liquid, and it's the same in all direction. So we are going to look at this document that we have here. We have these questions here. And these questions are of the hydraulic press. We have an hydraulic press, and they are telling us that the figure below is showing an hydraulic press, and they want us to do the following. They have told us that if the cross-section area of piston B is 80 centimeters squared, and that of piston A is 2.5 centimeters squared, they want us to find the force at B if a mass of 60 kilograms is applied to piston A. And they have given us acceleration due to gravity as 10. So I want you to note the things that they have given us. We have piston A and piston B. So for piston A, yes?
Yes, sir. Teacher.
Yes.
Okay, teacher, like many people are not understanding maybe the terms you're using. So, and also one person has offered to help explain.
It's okay. Now, which terms should I use? Because in hydraulic press, what you have to understand is we are still on the principle. We are looking at the principle of the Pascal's principle, where pressure applied at one point is transmitted equally throughout the liquid in all directions. So I was saying that if you have a diagram like this, pressure applied at this piston is the one that moves, and it will be the same pressure at this piston. So there is, I think, no other term that we have used. There is no better term that we have used, and there is no simpler term that we have used. It's just to understand that pressure at one point will be equal to the pressure at the other point, and that pressure is force or out of area. I'm going to ask, let me see in the chat. There is someone who had told us who wanted to help the friends understand better.
It's food.
Is he still on? Can raise up your hand and I give you, and I let you speak so that maybe they can understand you better. If you are still there.
Is there?
Teacher, like when you take a look at, like on my video, yeah, I would like to explain it from here because I'm not the host to share. What
Okay.
is it?
They have done this, but
Press. So there is where they call the small piston and a large piston this side, whereby the large piston, for instance, as just said, a vehicle, that's where we're going to put our vehicle, and that's where I've labeled it load. I understanding. And then here is like that pressure. That's why it just called it. I don't recall well, but piston one. Let me call it piston one, and then I'll call the large piston piston two. And then here, if you take a close look, here's a fluid. You get it. So when you apply pressure in piston one, the small piston will exert some pressure to this that will lead this fluid to rate high the load of the vehicle. For instance, it once used the garage, it will have to rate the vehicle. Hope you're understanding. And then the small piston application will be pushed to apply the pressure to this fluid, whereby this pressure will come all the way around and then push the large piston, and then the load will be raised up. Hope you're understanding. Thank you.
Okay, has Hood explained to us well? Yes. Yes. Van, your hand is up. Please, you unmute and you speak. Oh.
So we try to understand.
Paula, you have your hand up. What do you have to say?
Sir, is Food trying to mean that pressure is exerted or is transmitted equally to all parts of the fluid?
Yes, that is what the principle says. When you apply pressure at one point, it will be transmitted equally throughout the field. Some books add on that in all directions. So that means what he's saying is true. Okay, so if you have at least understood what you are saying, then I want us to try out these questions before we leave. There is a question there, question 1. I want you to read through it and we see how we can do it. I want you to read through it and then we see how we can do it. Okay, if you read through this question, yes, Food, your hand is up. What do you have to say?
As in, yeah, when you take a look at the question, it says if the cross-section of area of the piston B is 80 centimeters squared and piston of area, piston A is 2.5 centimeters, find the force exerted on piston B if mass is 60 kilograms. So if I've calculated, I've got 600, the units for force, it's 600. When I've calculated force, I've used the formula for mass times acceleration to gravity. And then what I'm not understanding is that how to get the force applied on piston A.
Now, what we have to do is, they have told you that piston A, I want you all to pay attention as we do this number. Let us do this number together. They have given us that at piston A, there is a mass of 60 kilograms that is applied at that piston. So they are asking for the force that is exerted at piston B. Now, since to calculate this number, we need to use the Pascal's principle. What we do is we first change this mass here into a force. So what we'll be having will be force at piston A. So force at A will be equal to
Force at B.
the mass. No, it's not like that. We are getting the force at A. So force at A is the mass that was applied at A times the acceleration due to gravity. So that means the force at A will be 60 times 10, which is acceleration due to gravity here. So if you multiply by 10, you'll be getting your force at A as 600. So the force at A will be 600 newtons. Now, after getting the force at A, we have to remember that Pascal's principle says that pressure at A will be the same as pressure at B. That is what the principle says, because pressure exerted at piston A is transmitted equally throughout the liquid to piston B. So please, can you mute your microphone first? First explain, then you come back. Okay, thank you. Then after having that, remember pressure, we said pressure is got from force. Pressure is got from force over area. Now, to calculate this well, we need to put this area in, we needed to put it in meters squared, but it's okay. Because they have not asked for areas, it's okay. Even if we leave it in centimeters squared, later we'll be getting our answer of force in newtons, because for it, it has changed from mass to force. So that means here we'll be having our force at A, which I'm going to call FA. If I divide it by area at A, it will be the same, or it will be equal to the force at B divided by the area at B. Now, because they want you to get the area, they want you to get the force, sorry. They want you to get the force at B. Now, what you will do is you just have to replace. You have force at A, you have it. You have area of piston A, you have it. This one, they are saying it is equal to force at B. Now, this is the only thing that you don't have. You don't have the force at B, but you have the area at B, which is 80. So what you are going to do is you are going to replace where you have FA, we are going to put 600 because we got it. Where you have area A, you are going to put 2.5. Where you have area B, you are going to put 80. And the only unknown you will have remained with will be that area, that force at B. So we are going to be having, our FA is 600. So here, instead of having FA, we are going to have 600 If you ask me where 600 is, we have got 600. It is from multiplying the mass in kilograms times acceleration due to gravity. And where we have area A, we are going to put our area A, which is 2.5 from the question, 2.5. Then force B, we don't have force B, but we have area at B, and area at B is 80. So after having this, you see that you only have one unknown, which is the force at B. So what do we do for that? We cross multiply. After cross multiplication, you will see that you'll be having 2.5 FB being equal to 600 times 80. So this is 600 times 80. So after that, you will be getting your FB. I will be getting our FB. Be getting our F of B from 600 times 80. Then after getting that answer, you divide it After getting that answer, you divide it by the 2.5. Now the answer you'll be getting will be in newtons. I know which answer you'll be getting. The answer you get is in newtons, not in pascals. The answer will be in newtons because we are looking for force. So some people have told us that we get our FB as 19200, and this is newtons, not pascals like Tima has put in the chat. It is supposed to be newtons because we are looking for force. So briefly, that is how we could use Pascal's principle to calculate that question there. Okay. So there is question 2 on screen. There is question 2 on screen. Can I have you people trying it out? Now, when they say diameter, even if you don't calculate the area and you use the diameter straight, force out of diameter, you will be getting the same thing. But if you are okay, you can get the area of the piston from pi r squared, because when they talk about diameter, we just know that what they are talking about is a circle. So these pistons are circular. You can get their areas of piston A and piston B using their diameters. And then you will look for the force at piston B like we have done. So you can try out number 2 and we see which answer you get. Yes, Ivy?
Okay, sir. According to this case, like, what will the area be in centimeters or meters?
Because for which it's easy to change, it is okay to put it in meters. But whatever case it is, I'm sure you'll be getting the same answer for force.
Okay.
Yes.
Teacher, for me, I've got 300. I've got, teacher, like, I could not like talk them, but it's 3800 newtons.
308
00 newtons.
for number 2.
Yes.
Okay, let's see what others have. Let us wait and see what others will get as number 2.
Okay, sir. For me, I've got 30800 newtons.
Okay.
But I've used this method whereby you said we can make the diameter of 2.
Okay. Yes. Tima, you were saying something. You have your hand up.
Teacher, me have got 1,540 newtons.
1,540 newtons. Okay. Let us wait for the answers other people will get. Other people, when you get your answer, you put it in the chat. We see. The question is still on. The question is still on. Okay, I'm seeing people are getting different answers. Let us try it together here. We see 14 to 8 is 77. Okay. Now we have, we said that force we say that force A out of area A is equal to force B out of area B. But I've told you that it's okay, even if we use the diameters, we'll be getting the same answer. I assume it's the same thing. So FA, they have given us 77. Area A, they have given us a diameter as 14. Another person can first get the area using pi r squared. And if r is 14, if diameter is 14, that means radius will be 7, and 7 squared will be 49 times pi. So that is if you have used area. But I'm going to use diameters straight, and I see what I get. So this is force B. After getting force B, the diameter that they gave us was 280. So now if you do this, you realize that your FB is equal to 280 times 77 out of 14. So if we calculate well, so we are getting our answer as 154 and 0, and these ones will be in newtons. So our answer is 1,540 newtons. That is what we are getting. So that is how we can calculate using the Pascals principle. And I think we have come to the end of our lesson for today, because we have to go for ICT training. Yes, soon. So please, you will allow me stop here, and I wish you a nice ICT lesson. Yes, Ivy.
I just wanted to inquire why you didn't find the area.
It is okay. Some people can get the area, some people can use it directly as it is, because even if I use the area, the following things will not change. The pi will not change. It will be the same, so it can cancel out. Even when I divide diameters by 2, that 2 will be the same on both sides, so it will not change anything, the answers. Yes, Davin.
Closing prayer.
Okay, you pray for us.
Okay, have yourself a word of prayer before God. Thank you for the lesson we've had. Thank you that we have come up with an understanding. I pray that we are going to have a Jesus' name I pray. Amen.
Amen. Okay, thank you so much. I beg you, don't go away from here. From here we leave, but you people will stay behind. for the ICT practice lesson. We meet again next week. Okay, which question? Sorry?
Has a question.
Yes, you ask.
Okay, so me, I was just asking if anyone has the link for the group to send so that I can join the group. Me, actually, I don't know anything that is happening. I just get the link for the lessons from my elder sister.
Okay, I have. Okay, you give me a little time.